Hi everyone. Welcome back. I'm sorry it's been so long since I've posted. The I had a few school really got up to me, but I'll be back to my regular posting schedule. Um, okay, so the first thing we're going to talk about today is the process of what's known. So in embryology, right? Embryology. Embryology is the study of basically how an embryo forms. The human embryo, or any embryo actually, how an embryo forms. And today I'll be going over how the brain forms. Brain in humans. Forms, right? Okay, so first let's go over a quick recap. When you're at a certain age, I believe it's 3 weeks, you are basically, here, let's make it sick. You are a layer of three layers of cells, right? Um, from the previous video or a few previous videos ago, we talked about your three layers, which are your ectoderm, endoderm, and mesoderm. You guys, so basically, just for a quick recap, what the difference between each one of them is. Ecto, I'm sorry, my pad is having some troubles with calibration today. So ectoderm is basically the outermost layer. Mesoderm or mesoderm, I've heard people say it both ways, is the middle layer, and your endoderm is your innermost layer. Actually, I'm going to make that a little thicker. It seems a little bit too small to see right now. Okay, so we know from the previous videos that our ectoderm is what becomes the brain, right? Ectoderm becomes CNS and PNS, right? So how does this happen in the first place? Right now, quite literally, if you look at this from the top, all you're going to see is this oval shape. That's you at 3 weeks, right? How does this flat shape come to be a whole brain and an embryo together, right? That's a really good question. Let me just finish coloring this in. Okay, I'm back. So basically, how do you go from this flat disc to a whole brain, right? So the first thing that happens is basically the thickening of the neural plate. Oops, that's too thick. Let's change your thickness. So the step one is thickening of the neural plate. Thickening. Basically, what that means is that on the ectoderm, there's a small region that begins to thicken towards the center, which becomes your thing called your neural plate. So that's just, remember, plate is flat, right? So it's just a thick, flat. It's just becoming thicker and thicker, right? So now here's a good time to take a cross section of the embryo, right? This isn't exactly a completely accurate depiction of what a cross section of the embryo looks like. So here, let's take a section along the neural plate. And what you'll essentially see is something that looks like this. This is, remember, your ectoderm. This stays the same. What looks actually very significantly different is, let's see if I can get it to highlight kind of thin streak. Okay, red is your mesoderm. Your mesoderm doesn't actually look a lot like what we imagine it to be. It's not just plain like that. Oh God, that looks horrendous. Stand by, people. Stand by. Sorry. Okay, good enough. So what happens here is there's actually additional structures present in the mesoderm, which the most important one, in my opinion, is something called your notochord. It's located right here. Your This structure is called your, let me thicken that up. Notochord, right? Here there's usually some structures. These are like parts of your mesoderm called your periaxial mesoderm. You don't need to know that for the brain bee or really, actually you might need to know that for the NRB. We'll get to this in future videos. But for now, all you need to know is the basic part is something called the presence of a notochord, right? And then obviously you have your final ectodermal layer. Let me just draw that out, a really thick one. And no, there isn't that much space. I just want to draw it so that you can see it, right? Step two. Oops. Okay, let's change up the color. Step two. That's so thick. Okay. Step two is the formation of the neural folds. Formation of neural folds. Okay, so what does that mean, right? So basically, right now, the goal is to make your CNS right now. What does the CNS look like as a really broad view, right? Like, I know this is probably a huge over-exaggeration, but it helped me think about it the first round, right? This, 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 right? If you look at the brain, technically, you could just see it as one hollow tube, like, well, not hollow, one tube with a bunch of thickening at the top, right? This part is just super duper thick. Like it starts to get super thick around this part, and then the remainder is just normal, right? So that's essentially how the brain forms. So the goal here is to form your neural tube. So how do you go from a flat surface to a neural tube? Well, the notochord initiates the ectodermal cells bending, right? It causes a bending in the ectodermal layer. So it will create something that looks a little bit like this. Okay, I'm just gonna color that blue part in. So what happens is the notochord basically causes it to bend inwards, which creates these two bumps called the neural fold. So the neural fold formation basically is the starting step, right? Because that's when you kind of get to see um how these two cells will connect together, right? But here, let's go back and I'll finish up drawing the remainder structures. Meanwhile, I suggest you kind of think through what just happened, the transition from step one to step two. Okay, so now you can see the formation of the new notochord cells. So here's a quick fun correlate, right? So near the tips of these, there's a parts of the few types of cells here called neural crest cells, right? Neural crest cells. Just remember, this will become heavily important in the next step, but just keep your eyes on these, right? So finally, the last step is the formation of the neural tube. Step 3, neural tube. Right? So what happens is now your thickened ectodermal layer and your folds will merge together, causing the overarching ectoderm, then your nice neural tube, and how convenient, the neural crest cells will kind of just hover over that piece. And neural crest cells basically migrate to different parts of the body during development and act as kind of mesh cells. So for example, neural crest cells become melanocytes, which are basically the cells that provide pigment in your body, right? Or they become the basis for teeth. They also become endocardial cushion cells. So basically, when your heart is separating into the different chambers, there's when I believe the ventricle is the right and left ventricles are separating, the endocardial cushion, there's actually a few neural crest cells that migrate over there to help form the wall, right? But anyways, that's kind of it's relevant, but it's also not relevant. It's just a fun clinical correlate. Um, there's your Nordic cord. There's the endoderm, and then our favorite layer, the mesoderm. Mesoderm surrounds your notochord and your neural tube, and then from there on, you're created with this tube-like structure, which I'm drawing in blue. I'm taking this out of perspective, right, of the just like the tube. I'm just like putting what I'm trying to say is like I'm gonna draw it as a tube, right? So the tube, what is gonna happen now is the tube looks like this, right? It's going to start to close from both ends, right? It's gonna start closing from the caudal, just towards the tail, and the cranial, which is towards the head. The head end tends to close typically faster than the um tail end, caudal end, and this one, the head usually takes around 25 days to close, whereas the cranial caudal end takes around 27 days to close, which is a little bit longer. So now let's talk about the possible things that could go wrong in this process. First is that what happens if the head end doesn't close properly, right? What if this doesn't close? What that condition is called is anencephaly. Anencephaly. Anencephaly is the improper closing of the neural tube on the cranial end. So cranial means head. So as you can imagine, what anencephaly leads to is essentially an unclosed brain. It's going to lead to an improperly developed brain and an unprotected brain. So what that means is that the fetus will most likely not be viable should the person have anencephaly. Well, what if the tail end doesn't close properly? That's called spina bifida. So bifida. And this is a condition where the spinal cord, um, and so basically, yeah, the caudal end doesn't close properly. So this one isn't as fatal as anencephaly because your spinal cord, yes, also it's important. It's not as severe, I guess you could say, as having like an unclosed brain. Like Do you guys get what I'm saying? Um, and yeah, that's actually all for this video. It's a very complicated process. There's a lot of other videos that I suggest you watching as well. This is actually pretty oversimplified. I just wanted to put this video out there so that you guys could have a foundation to build off of when watching the other medical teachers teaching this. Like, I know there are a few other really good YouTube videos that I watched, some animations. Um, I also highly suggest learning about a process known as gastrulation. If you're interested, that's how we get to this stage in the first place. So you know how our embryo is 3 layers. How does that happen in the first place is gastrulation. Um, I think it gives a little bit of nice perspective into this whole process as well. I also suggest looking into neural crest cells. These are pretty, really, really, really important cells in development. And the improper migration of these can result in various conditions that would cause basically certain limbs to not develop in the first place, right? Um, and yeah, I think that's about it. If you guys have any questions, please leave a comment down below. I was finally able to fix the comment sections now, so you guys should be able to comment. And yeah, thank you so much. Bye bye.